Hi there. In recent years, I've seen a huge increase in the number of Wi-Fi and BLE use cases for mining, from location tracking to safety monitoring. Ian Procyk has been deep into the details of industrial location and safety use cases, and he will walk us through examples of how all of this works. Here's Ian.
My section here is going to focus on what we're doing with what a lot of people have already, which is Wi-Fi, and some of the newer equipment has BLE enabled in it. Kevin, my colleague here, is going to come up right after me and talk about the LoRaWAN piece because it's very much related to this. And in the top right-hand quadrant, we have another really good guy, Derek, on the line for tomorrow, queued up to handle anything around 5G cellular. And I think Derek's on the call today as well. So if there's questions related to NB-IoT and sensor networks on cellular, he certainly can chime in there as well. So with that, we'll get underway, and I'm going to want to try and make this interactive. So if there's questions, Roland, feel free to jump in. We'll try and address them as we go by. So I always like to start things off with a bit of history lesson here, and for context, because it's really important. That's actually an image generated by Midjourney. That's an AI generated image. I asked for a historical miner working on a mainframe, and that's what it came up with. And so interesting. So we've been doing Wi-Fi for a long time, as probably most of you are aware, right? This is location services specifically for about 16 years. If you go all the way back to the origins of our very first location appliance, back then it was all about just getting the basic RTLS systems, the very first generation of AeroScout tags. And RTLS is a big term, but really when you boil it down, what we're doing is they're transmitting a Cisco compatible beacon that is received by all of our access points, and sometimes that payload included telemetry information as well, so you could get battery voltage and tag shock or movement and that kind of thing. But often it's just, I'm here, this is a transmission with an address that you can trace. And so that was how things got started off. And I think Cisco holds a unique place in the industry here, being the largest operator of location networks globally, and you'll see that in a sec. But a lot of this comes from the work we've been doing in the enterprise for 20 years, right? That's where a lot of this stuff got its start, and it's trickling down and across into other verticals. So a lot of you on the call probably running some form of mobility services engine, MSE. And I highlighted in red there that is actually well past its due date. But the mobility services engine was our second generation of location services equipment. It's since surpassed 2 generations with other things, CMX and now something called Spaces, which we're going to focus on today. But all that to say that was our second, hardening attempt at location as we started to get the iPhone era and mobile devices starting to come on, right? Lots of handheld devices came into the network in the mid 2000s. We needed to take a handle on, redesign the database to get more scalability out of the system, especially in big enterprise. And then we started introducing things later on-prem called CMX, Cisco Mobility Experiences. CMX was our first look at basically making this more than just a RTLS system. It was reporting and analytics in the platform to some extent. And what we've really gone through in the last couple of years here since 2019 was moving first and foremost our development efforts to cloud, like a cloud first model, because if you can understand from an integrator's perspective, from a partner's perspective, if they go to one site and the person's running MSC version 7, they go to the next site, the person's running MSC version 8, the next site, they're still on the location appliance. There's no consistency in approach. So a lot of integrators and vendors that we work with as partners struggle to deploy and maintain high scale systems when every time you touch a different system, there's a different API call, there's a different version matrix of software support and all the noise that goes with that. So with doing this as a SaaS model in the cloud, we're streamlining that significantly. And the evidence, I'm talking to some of the people that do support for this offline, and it's making a huge difference, a lot less air travel required to keep things up and running. So all that to say, that's where we are and where we've been. When you look at the actual size of this deployment now in the cloud, it's world-class, right? So you see just shy of 3 million access points deployed, 14 trillion location updates. This is actually off of a web page we maintain that keeps track of all the telemetry coming into the system. Almost 2 million tags. So those are RTLS tags, traditional Wi-Fi tags, or BLE tags. And you can see the number of visitors we're tracking here as well. Pretty impressive. So I'll let this build out a sec here and kind of explain what this is all about. This is Spaces. It was formerly called DNA Spaces, but we're making this across all of Cisco, so it's no longer just a Catalyst side play. This is integrating data from Meraki, from WebEx. So we're taking the data from multiple sources here. Sensor data, think about occupancy data, pressure, temperature, humidity, those types of things that we have on some of our access points now, and some of the endpoints that we manufacture, of course, and then all the BLE and Wi-Fi device ecosystem that's out there. So all that data feeds up into our Spaces cloud, and then from there onwards to either your own APIs that what we call our Firehose API, which you can query as an end user, and I'm going to talk about that a little later on. And you can set up data streams and telemetry streams for custom integrations there. We also have a whole partner ecosystem around this, like Pointer and others there. You can see MazeMap that do kind of turnkey solutions for an additional cost, right? So taking that location data, custom dashboards, custom use cases around that kind of thing. All this is backed up. We run this in AWS, right? So that's basically how we're dealing with this from a cloud hosting perspective. You don't need to worry about the back end. That's our job, right? So this is different from how we've approached location in the past, where you're doing all the care and feeding of a VM or an appliance on site, right? And maintenance windows and code upgrades and making sure that version matrix lines up with whatever controller software you're on. That's what we're trying to get away from. We're trying to make this a high availability system that is consistent, that has the same APIs across the globe. For those of you international customers in here, data compliance and concerns around data sovereignty, some of that's addressed as well with some regional data centers. Not every country, but certainly in Europe and North America, we have separate facilities and GDPR compliance as well. This is just a total, 30,000-foot view here of the system and kind of some of the outcomes we're trying to drive with this. A little bit of an enterprise slant here, but nonetheless, a lot of this is directly applicable to anything in heavy industry. I think the big thing that I'd like to key on here and highlight, because I run into this all the time with customers challenged with science projects, right? I'm a big fan of playing in the lab. I love hacking on gear and testing new stuff. It's one thing to do that, and then one thing to try and make that work at scale in production, right? So what we find a lot is projects that are run by different groups in an organization. You've got something that's run by the IT department, something's run by ops, something that's run by, maybe the warehouse guys for inventory control. At the end of the day, a lot of this stuff is Wi-Fi or BLE. Why can't it run on a common infrastructure and take advantage of a cable drop that's already there? Take advantage of coverage planning that's already been done, perhaps. So these are services that can ride on top of an existing infrastructure, and that's why I said at the beginning, this is kind of taking advantage of what we already have. If you've got a Wi-Fi network deployed, well, obviously we can be pulling in anything that's RTLS and Wi-Fi at 2.4 gigs, and we've been doing that forever. Now with the last kind of 4 years of access points, we have BLE capabilities for receive. BLE is not a technology you want to use for long haul telemetry, like across an open pit mine. It's not the appropriate technology for that. But underground plants, warehousing, indoor spaces where you're typically dealing with a few hundred feet of range, that's more the place we want to be. When we think about outdoor and long range sensing, that's going to be more of the LoRaWAN conversation, which Kevin's going to talk to later on. So we're trying to move this towards DNA Spaces, or Cisco Spaces as it's called now, and a common architecture, common model that allows us to homogenize all this into one uplink, if you will. So review the use cases here, right? So this may be reviews for some of you.
Respond to people and how they adapt to people. Buildings use 40% of all primary energy. For me,
just going to pause that for a sec. Are you hearing the audio on that, Roland?
Yeah. Yeah,
okay.
We're good.
So I'm just gonna give this played automatically before I could click off. So I just want to give a bit of a review of this. This is an example of something that Cisco did related to energy savings and ventilation on demand in the enterprise a few years back with the University of British Columbia, and it's trickling down to what we're seeing happening now with smart buildings and the sensors that we're now offering in our marketplace that kind of do a lot of this telemetry. This is a couple-minute video. I'm going to play this out. I think you'll find it interesting.
Pursuing sustainability, it's a great sector to be in because there's so many improvements to be found.
Cisco has a very long-term relationship with the university. There's a lot of collaboration between our engineering group and the university that has really helped to shape our overall wireless product line over the years.
Colleague at UBCIT, Jeremy Coho, and his group, they invited me to come over for a visit. And in that room, they have big monitor screens that are showing all the Wi-Fi analytics that are happening simultaneously.
In September, we're expecting 60 to 70,000 concurrent clients and 120 to 130,000 unique devices every day. Supporting that is about 5,500 access points.
The light bulb moment is when I realized actually that data could be used to make buildings smart, to make buildings responsive to people.
When Stefan first approached us, we were pretty excited. Working with him was really nice for us because we get some intelligence out of that data now.
So essentially what we're doing is we're using the Wi-Fi access points as a sensor network. The solution tells you when people are coming, when people are leaving a space, how busy a space is at any one particular time. And what we're doing is taking that data and sending it to building control systems, which means that the building can respond really quickly to where the people traffic is.
What Cisco brings into this is the ability to accurately show how many clients are connected and where they are. That's the key that we never had before.
So when I realized the potential of this data, the first group that I got in touch with was UBC Energy and Water Services, Blair Antcliffe and his team. We built a very simple pilot with the support of UBCIT, and from that performance data we could see we're getting 5% energy savings.
Normally we have to fight for 5% savings. We have to usually spend a great deal of money to get 5% savings. And so seeing that success, we wanted to roll this out.
We saw that this was something we wanted to be involved with. We actually provided them a couple of appliances that they would be able to run CMX on to be able to conduct this more across the campus.
So UBC has over 1 million square meters of floor space. It's a small city, frankly. If we can expand that out to the whole of campus, we're looking at between $200,000 and $400,000 worth of energy savings on an annual basis. UBC has some of the most ambitious climate targets for any public organization in the world. And already we've achieved a 33% reduction in greenhouse gas emissions below 2007 levels, and we're looking to push that to 67% in the next 5 years. If we can get savings campus-wide, it's a huge accomplishment for not a huge amount of money.
This is a transformational type of a project where we can take this beyond UBC. We can take it to our partners in the building management space. We can take it to our customers around the world, and they can see the same benefits.
This would not have happened without the extensive teamwork within UBC and from our outside partners like Cisco.
Wi-Fi analytical systems have not in the past talked to building control systems. And that in itself is a breakthrough to help buildings become much more responsive and intelligent towards occupant needs.
All right, so I think a really interesting video from the perspective, obviously, of the enterprise, but certainly you can draw the parallels there between what we did. And I used to work at UBC with that crew years back, and we maintain a really tight engineering relationship with them. That concept, I think, was ahead of its time, right? On all honesty, and what's that's trickled down to. We did a case study a number of years ago, another field trip here I was on at that time, Goldcorp, Eleanor. Up in northern Quebec was one of our case studies around ventilation on demand in an underground mine. And for them, this is, directly attributable to energy savings in power generation and diesel a lot of times, right? Trucking diesel into the remote locations for your blowers and fans that frequency drives that need to run megawatts of ventilation. And you can see a picture there on the right of the propane, CO2 sensors, et cetera, that are down underground. And this is all tied together. The company integrator involved with this was Meglab. So this was again using an early version of CMX at that time, and it was really cool. I mean, this is early days of providing Wi-Fi connectivity underground. We also had a couple other use cases here that I see across the country intermittently, but digital tag boards, right? So again, leveraging AeroScout tags, industrial tags that have been around for a long time, are well proven, that you basically, even as a guest, a visitor to the site, you are given a hard hat, and that hard hat has a tag on it that is tracked, and you have to sign in and put your name against the board. Of course, there's the manual physical backup that's regulated and required. We're not replacing that, but this is a very fast way of looking where things are. You can actually see on the helmets here the tag locations. And so this is not only on people, but it's on anything with an internal combustion engine underground. So all the Land Cruiser fleet underground, anything that's a generator that has a key on, key off, right? If we can get a message from the vehicle saying the engine is running, we know hard-coded into the system is the displacement of that engine. We know the airflow requirements to keep air fresh when that vehicle's running in the area. It was actually interesting being able to walk down some of these drifts and then be in there for 10, 20 seconds and then feel a breeze start to flow against your back as the ventilation ramped up, because it would detected you in the area, right? And again, it's a huge savings in this type of operation. Doesn't apply to all types of underground mines, granted, but when it does, it's another service you can overlay on an existing network that's there. And you can see a mobile view application here. This is the AeroScout mobile view application for actually looking at some of the asset tracking underground as well. One of the largest, if not the largest, deployments of standard RTLS in the world is up here in Canada. This is one of my customers in the oil and gas business, and they rely on Ventus, Industrial Scientific Ventus gas detection tags. And the tags they have are slightly older than what I'm showing here, which is now an LTE capable CAT M1 version. But these tags are a man down. There's a tilt switch inside. There's a panic button. There is, of course, a CCX or a Wi-Fi transmitter in there that beacons out all this telemetry. So controller room operators actually get real-time information about, if there's a gas cloud moving across the operation, or if somebody's having an issue. That's fed back to the control room and put up in big red letters if there's a problem, and an alarm, actually, an actuated alarm comes off. You can see on the left-hand side a screenshot I took years back when we were on site looking at the actual location of all the people and personnel, walking around. Pretty impressive. And this is a couple kilometers wide. This is being covered at that time by Wi-Fi, outdoor access points. Resolution here, typically like 20 meters, right? It's enough to get close enough to hear or see. Roland, go ahead.
Yeah, no, I was just curious. Is this during a shutdown, or is this how many people are normally there?
This was actually during a normal course of business, not during a shutdown.
No kidding. That's a lot of people.
And one of the you can go online and look this up, and the various trade unions had posted notifications about the system going into use because, of course, people are concerned about location tracking. But it was very public. It was very well published, and it was part of your PPE. You weren't allowed onto the site without a tag if you were operating in these areas. So they do some reconciliation on and this is also jointly work with us and Accenture. They do some reconciliation around billing, right? If you're a contractor and you claim to be on site for 8 hours and you're actually there for 2, that kind of stuff. But obviously the life safety aspect of this is why you spend the money on the tag in the first place and have that there. I actually had to work in the back end to do a bunch of testing with these guys to make sure our system was able to scale, to your point, Roland, about when a turnover happens and you have 5,000, 8,000 people on site. What if they all converge in a certain area of the plant or an outdoor muster spot? Like, can we actually support that number of tags? I had to go through a whole exercise with our engineering group to make sure that that was something that we could scale to, not only in the older platforms, but the new stuff that we have out now. I wanted to show you a little some of the dashboards behind spaces here and what they look like, just so you can see. I've got some screen recordings here. I'll let them play out and I'll just talk over top of them. This is the dashboard you'll find if you log into Spaces. There's a bunch of different pre-canned apps that are on here, and the idea is that you have your map hierarchy that you might have had for years in Prime Infrastructure or now maybe DNA Center loaded into the system. I'm showing you an example here of a an occupancy detection sensor that we have communicating over BLE. And so if you just click on the occupancy detection sensor, you can see we got a basic rules engine that's in the system. So we can actually go in and add our number of sensors. We can create some basic rules about, hey, is this particular sensor, you know, how long do you need to be present for that to detect? You'll just flip through the views here. You'll see the hierarchy of the map show up in a second. Of course, indoor example here, but you know, you'd replace your mind map on here. And so you can click on the actual sensor and see what it's telling you, what its location is. So it's critical. Garbage in, garbage out. You need to know where things are in the system before you can actually start making value and getting value out of them. And here's the particular sensor details, the battery voltage on that, and the location of the tag last heard. The occupancy history here, I'm just going to change the view and show a historical view of kind of a time series chart of, you know, when that area was last occupied. All sorts of use cases here. And here's the rules engine, very straightforward. This is just the room occupied alert. So if we're occupied for 20 seconds, we log in an event, we send an email, we send an SMS, and we also have an automatic API hook into WebEx. So we can push a notification to somebody, perhaps at a desk or a security desk or that kind of thing at a console. And an event log you can see here as well. So that's an example of one of the dashboards that exists inside of Spaces in the cloud natively. And of course, it's kind of like a WYSIWYG editor. You can go in and add sensors, add applications, add your different rules, and change them here on the fly. The next one I was going to show here, just a second here. I need to show the next image. I think it's going to play up here properly. Just one sec. My PowerPoint is giving me a stroke. The detect and locate app. There we go. So yeah, some sort of infinite loop here. So detect and locate is another app that we've had, and this is very similar. If you're familiar with CMX or MSC, we always had a way as an IT admin to go in and just check, you know, is the system responding correctly? Am I getting location data? Can I see my assets? And in some cases, people would have had other third-party downstream systems they would have used in the past for this. We support a lot of that natively now in the system directly. And this is what this looks like. So same landing screen. You come into the app and you can see here, I'm going to click on the detect and locate portion here in a sec. I'm just scrolling down and showing you the other apps that are present. An example, the very bottom here, the IoT device marketplace, which I have a slide on in a sec. But detect and locate here, we're tracking 2,700 devices in this particular instance. And if I bring up the map here, again, this is one of the labs in San Jose, and I can show you the location of the building. Of course, you can tie this back to geo coordinates. So most people have geo Latin long defined tags in their mapping infrastructure, so we can actually know where that building or that map or that space is in the real world, not just at some random XY coordinate. If I just filter down here on the different devices, I can filter off my views of Bluetooth tags, rogues, rogue clients, etc. Here's the details on a particular device. So I'm showing you a Wi-Fi client. So anybody with, like, people are traveling with smartphones underground and in the mine and the plant these days. So anybody that has a Wi-Fi enabled device, if they're authenticated onto your network, you're going to get really good results of location. The days of getting just probe-based location information are pretty much gone. You need to have a Wi-Fi device that is connected to your infrastructure, and you can see the location history of where that device has been traveling. Even if this device moved across multiple buildings, multiple floors, you can actually do a step-by-step playback to see where that thing was. Whether it's an asset tag, a BLE tag, or somebody's iPhone, right? You can do the same kind of playback and see what's going on here. So that's the name of the game with this. Some device tracing here as well. If you're from an IT guy's perspective, you're curious as to how is this flowing in? Is it picking up from all the right APs? Have I got my maps correct? That's all stuff you can define here. Some very basic capabilities of tracking and selecting what you want to track to maybe eliminate noise floor. Like if I don't want to listen to RFID tags in my environment, I want to speed up the scanning, I can actually have fast locate running, which uses some of our more modern access points to really increase the scan interval of BLE tags and Wi-Fi devices. I can adjust my filtering and my cutoffs here. This is all stuff that was in previous versions, it's just not as easily accessible. This allows you to get a little bit more granular with how relaxed your coverage area is going to be for detecting something, or if you want to get real tight in a specific spot. Notifications are cool. So like I was showing the rules engine for the tags, you could do a notification to on a custom webhook to push any movement change parameter that you want outbound. So if I want to alert based on something, a device came into an area, left an area, I can do that as well in this tool. So that gives you an idea what we're doing in the detect and locate. And the last thing I wanted to show you here was the IoT marketplace, which is something that I think has been missing when you look at this from a broader, bigger picture, which is, okay, I've got all this stuff on the infrastructure side, but what about the tags? What about the sensors and the things that I can bring in? What does Cisco, number one, test? What do we approve? Who are the vendors we work with, right? So this is the idea behind the IoT marketplace. The same thing in the dashboard. I'm going to scroll all the way down to the bottom. I'm going to dive into that marketplace. And when we go in here, you'll actually see, sign in one more time. And the idea is I can filter based on my application. So maybe I'm looking at this from more of an enterprise operator's perspective. I can do that. I'm picking manufacturing use cases here because they closest align to this vertical. And I can say, you know what, show me all these different use cases here. Show me the tags that apply. So I'm dealing with my typically battery powered devices here. This is the stuff that we're testing and we're integrating with. So these are mostly BLE based tags in this particular view, but I can sort on the left-hand side. You see we're starting to experiment with ultra wideband and a few other things as well. Contact.io is one of our big partners here. And so some of the occupancy detection stuff that I was showing you earlier is coming from them. But check out this nano tag. It's $8, right? So this is an IP67 tag, 2 grams, literally your wristwatch style. You could sew this onto clothing. You could put it on a keychain. You could do a number of things with this. If you're trying to figure out where something is, this is a really low cost way of doing that. If you want something with a bit more battery life for a bit more money, Contact.io makes a tough beacon that is actually got one behind me in my toolbox here. This is a 4-year battery life on this particular tag. And the idea here is that particular tag is using BLE. And there's a data sheet for it there, minus 20C to I think plus 65C operating temperature there. Smart badges with like you could do like any kind of lanyard replacement stuff. You can actually do ID based on that as well. So there's all sorts of things you can do here. You can play around with the different filters on the left-hand side to see what we're dealing with in different technologies, all of that. So that's the IoT marketplace in a nutshell, and something that I think is we're growing that. I mean, I've been watching this for the last couple of years as we've been adding more and more things to this space, and it's growing like a weed. I'm going to just pause there, Roland, to see if we have any questions that have come in.
I was going to interrupt you. I have a question I have to ask, right? Because
Sure.
Forever, you and I have been dealing with mining companies, and they're always saying, like, this is critical stuff. We can't have it off the premise. And yet now you've spent the last 20 minutes talking about cloud-based, right?
Yep.
And so I just wanted to make sure the audience knows that that's not lost on us, right? I guess the question I would have is, how critical are these applications, or if they're going to go cloud-based, do they have to make sure that they're not relying on this for operations? And at that point, what value does it bring?
Yeah, absolutely. So like the short answer to your question is, this is cloud-based. What I'm showing you is cloud-based. We have a bit of a program around trying to break out some local telemetry that's not out there yet in major beta, but that's something we're thinking about. You could think about the worst case scenario. Let's say you're Carnival Cruise Lines and you're operating in a cruise ship environment. You want to do all this BLE tracking and stuff, but how the hell do I send this to, the cloud if I'm out in the middle of the ocean and I'm on satellite, right? Same thing in the mining industry, right? We're dealing with critical communications. So this is why we're keeping the on-prem CMX. We're actually doing a CMX version 11. We're keeping that available. But for these, I'll say less important scenarios, maybe it's occupancy, it's analytics, it's detection of things that are not maybe super mission critical. This is where we can start getting into the low cost, high scale stuff that's done via BLE. Yeah. And that's kind of the focus here. As far as, and I get into this in a bit here as to how we get data to the cloud, but one of the things that is important is there is a proxy way of getting data from your industrial network up into the cloud. And we actually do that through a connector that is a VM that's installed on site. That connector is actually a fairly lightweight VM. Now that connector is actually can be deployed in high availability, right? So we can actually have two of them in different parts of your network, two different data centers, different buildings or whatever, and or even different geographical regions if you want. And we do the deduplication on our side. So if you send tag telemetry up to us, we get it twice. We just take the first one we got and deep six the next packet. So you can do maintenance and shut down one of these connectors, that kind of thing. So we're thinking about this from a high availability at the edge perspective. Of course, I think more and more times we're getting customers with redundant links, low Earth orbit satellite connectivity, and some of this stuff for some of the connectivity options that, if your fiber gets cut or taken out, that kind of thing. So I wanted to spend a few minutes here just around location telemetry and how we're getting stuff out of the system, because this is again an effort we're pushing on here. So the concept here is this is an open platform for all sorts of different things you might want to do, right? And the way in which we're doing that is leveraging an API subset that's mostly push, right? So we really want to focus on high scale. This is not a query response type of situation at scale. This is we are going to send you, Mr. Customer, and your downstream apps, whatever you're asking for in real time, right? That's the idea. So we call that our Firehose API. And that's what you see here. So the idea is that you as a customer can sit and define your applications, define your use cases as a quote partner of ours, right? So you sit natively in the dashboard. You have a connection to the cloud that can consume this. That the consumption can be back to an on-prem device if you wanted it to be. So the idea is, you set up your account in Spaces. Anybody can go do a demo of this. It's a free download to set up that connector and Spaces if you got existing Cisco infrastructure. You create your application in the dashboard. You define what events you want to be receiving, and that Firehose starts up. And depending on how much you select, the Firehose gets wider and wider, right? So you might have multiple applications you're streaming different things to. So to put this into perspective here, there's a fairly comprehensive set of API documentation that we're just not going to be able to get into the specifics on this call. But if you just do a Google search, Cisco Spaces Firehose API, like the first thing you're going to find is this documentation, and it's pretty in depth. You'll see all sorts of ways in which, if you want to get beyond just the pre-canned applications that I was showing you earlier, you want to start taking tag telemetry. You want to start taking state change. You want to start taking binary input-output values off of stuff. This API is going to be your friend, right? And the applications you can use to query it. There's an example of what it looks like under the covers here. So I'm actually showing you a BLE tags telemetry values here. As you can see on the right-hand side, this happens to be a temperature sensor with an accelerometer in it, as an example. Here's an example of what a client, telemetry stream would look like in the data model for that. So we get, for example, the actual map coordinates, which are relative to us. If you have that geocoded, we'll actually give you a Latin long. We get the actual calculated location time, which is NTP synced. So first heard, last heard. The signal strength, as you can see down here, neg 53. If I scroll down a little bit further here, because this particular example is showing you some geocoded addresses, you actually get your Latin long here. So this would be your decimal degrees. And then you can kind of see, okay, what device is reporting. This is obviously a probe of somebody's Samsung mobile device. So we can actually get that information off of here. And if there was an association to a network, you can actually see IP and SSID and all that kind of stuff.
Question about that,
and
Ian. This is all really good. This is all really good data. Does this depend on what kind of wireless technology is being used, or is it the endpoint that's pushing it over BLE or LTE or Wi-Fi or whatever? Yep. Like how much technology dependency is there?
Absolutely. Anything that's a BLE use case is going to require an access point that has a BLE receiver in it. So to boil that down, that's going to be basically our 11AX and newer APs. Some exceptions to that rule. Our 9124 outdoor access point has BLE support, right? Again, limited range. BLE is not going to be a kilometer long protocol. For any of the Wi-Fi based stuff, let's say you're tracking a smartphone, of course, that's just Wi-Fi, right? So if you've got a Wi-Fi network, literally that's been you know, we can go all the way back to 2006, 2007 with and getting data from that kind
Do they
of
have
year.
to
So
log in? Like, do these devices have to
ide-
authenticate, or
ideally, so we can do some limited detections of probes. You know, we think this device is here, but who is it, and you know, like actually who's associated to it? That stuff is being randomized so much these days with the different filters on the different operating systems. It's better, to be honest, to have this, you know, really like you're tracking your corporate personnel that are on, you know, registered and connected to the network. If they're associated and connected and have an IP address, then this data becomes very accurate. The counts are very, you know, one-to-one. So
Okay.
floor maps, floor map data. I was just showing that a second ago. So again, this is a campus example here, but you have your mind map loaded in here. That's going to be scaled properly. But the cool part about this is you can take that map imagery and overlay where something is on that map, and you can pull that out via the API as well. So if you want to pull this up into a dashboard and say, hey, I'm looking for, I don't know, let's say somebody left a Miller welder in a drift somewhere, trying to figure out where the hell this thing is. It could have a tag on it, and you could go find out where that is, right? Or any other piece of heavy equipment as an example. And you can actually get a little image that says, here is where we think it is, right? And generally accurate here to the nearest AP. If you've got some triangulation, we can get this down kind of under 10-meter accuracy with Wi-Fi or BLE. Going beyond that level of accuracy requires technologies like ultra wideband or other more proprietary things that we're working on, but is not broadly applicable across the industry just yet. And that's the challenge, is a lot of the hardened industrial applications for this stuff take a little while longer to percolate, right? Just getting data to the cloud section here, I wanted to just spend a few minutes on this if we got some time. Just focusing on what it actually looks like here. So we have our tags at the bottom, and I'm showing BLE here, but this is also applicable to Wi-Fi. We have our tags at the bottom of the screen being detected by our access points, right? That's nothing necessarily that new. The access points have a CAPWAP connection to the controller. That's, again, nothing new. It's been around since 2005 when we acquired Airspace. This is the DNA Spaces connector. So this is that little proxy box that I talked about earlier that is the shim between your network and ours, right? So this is what is doing that telemetry conversion and reformatting to an SSL connection up to AWS and our Spaces cloud. So that's the idea here, and so there's actually a gRPC connection that's required down to the AP. So there's some ports and some firewall rules you might have to open in your environment to make some of this work. There's a whole port list and everything I've got in the documentation, but suffice it to say that's the idea. And if it wasn't obvious, you know, this BLE functionality on the access points is something that may be new to, I think, many of you. The access points have kind of two rules of operating, right? By default, any of our newer Wave, 11AX, like 9120s, 9130s, 9124s can all support a BLE receiver. And by default, they act as a gateway that can do one of two things. It can either sit and scan, so it can be a passive listener to the environment and it's detecting tags. So you go into the marketplace, you buy these tags, you have other tags you want to leverage that you maybe got through another vendor. BLE's BLE, where you can receive those tags and upstream the telemetry. The other part that's more advanced and slightly more expensive is if you actually want to start managing your tags. So or have the access point actually act as a beacon. So the access point can actually turn its radio on in reverse and start transmitting out like a lighthouse. And then that means that you can actually do some reckoning based on passing of access points. So we switch to a mode in this regard where the client is doing the detection. So let's say you have a smartphone that is underground, that is passing by an access point that's transmitting as a beacon. If that's the case, then this device can say, hey, I just heard this beacon. It's obviously an infrastructure beacon. It's on a cable. It's got PoE, so you don't have to worry about batteries. But this device can sit there and listen to that transmission and report it upstream to an application. That application can do the correlation that says, hey, I just heard this BLE tag. Where am I? Because we know where that infrastructure device is. I must be close by it. And so that's kind of the dead reckoning, you know, last known position as you pass along underground as an example, or in a plant or that kind of thing. So an AP as a beacon is an interesting concept. And this is the the last slide here, which is just the geek out version of this, but this is the ports and the connectivity to make this go. The big thing to point out here is that coming up to the cloud is 443 HTTPS. So this is our connector sitting over here. And this is your spaces shim in the middle, the proxy, if you will. That's the VM. This can be deployed in HA. You can have multiple of these. And this is what is, and used to talk down to your controller and of course down to the access points. So with that, any questions?
Hope you enjoyed this presentation from Ian. For more information on Cisco and the mining industry, check out cisco.com/go/mining. Take care.